April 28, 1945. East China Sea, 20 miles southeast of a Japanese convoy. Lieutenant Commander James Patterson gripped the controls of his PB-4Y to private air at 15,000 feet, watching the radar operator track for distant blips on the screen. Japanese vessels his crew would never actually see. In the bomb bay hung two ASM-N-2 Bat guided missiles, weapons so revolutionary that the Japanese Navy still couldn't comprehend what was hitting them even after multiple attacks. Target bearing 045, range 18 miles, the radar operator announced. These would be the only words spoken about ships that real humans sailed on, reduced now to glowing dots on a cathode ray tube. Patterson would release weapons that would guide themselves to impact while his crew turned for home before the enemy even knew they were under attack. This was warfare fundamentally transformed, not through courage or skill, but through American industrial capacity to mass-produce thinking weapons that remove human agency from the killing equation. The Bat missile represented humanity's first step into automated warfare, a primitive beginning to what would become the age of smart weapons and drone strikes. The ASM-N-2 Bat was the world's first fully automated guided missile to see combat use, developed by the National Bureau of Standards under the leadership of Dr. Hugh Dryden, who would later become NASA's first deputy director. Unlike German radio-controlled glide bombs that required operator guidance, the Bat was truly autonomous, a fire-and-forget weapon that used its own radar to find and strike targets without human intervention after release. The technical specifications represented remarkable achievement for 1945. The missile weighed 1,880 pounds with a 10 ft wingspan, carrying a 1,000 pounds N-65 warhead. Its S-band radar seeker could detect large ships at up to 20 meters in clear conditions. The guidance system used analog computing, vacuum tubes, and servo motors to continuously adjust flight controls, maintaining a glide path to impact. The development began in January 1942 when the U.S. Navy's Bureau of Ordnance recognized the need for standoff weapons that could strike ships beyond anti-aircraft range. The National Bureau of Standards assembled a team including aerodynamicists, electronics engineers from Bell Labs, and physicists from universities nationwide. By March 1943, prototype testing began at Naval Air Station Pawtucket River. What made the Bat revolutionary wasn't just its technology, but America's ability to produce it in quantity. While Germany struggled to hand-build small numbers of guided weapons, American industry manufactured approximately 3,000 Bat missiles, though only about 420 would see operational deployment before war's end. The program cost $12 million in 1940s dollars, roughly $180 million today, yet represented less than 0.1% of American military production. The Bat missile's combat debut came on April 23, 1945, when VPB-109 Squadron attacked Japanese vessels at Balikpapan Harbor, Borneo. The mission didn't go as planned. Both missiles failed due to technical defects, a reminder that even revolutionary weapons faced teething problems. However, subsequent missions would prove more successful. On April 28, 1945, VPB-109 achieved the Bat's first confirmed kill, sinking a Japanese patrol vessel in Balikpapan Harbor. The weapon had traveled approximately 9 miles from release to impact, with the launching aircraft already turning for home when the explosion occurred. For the Japanese sailors, death came from an empty sky with no warning, no engine noise, no visible attacker. The psychological impact exceeded the physical destruction. Japanese naval personnel had no framework for understanding what was happening. Their training emphasized visual combat, ship-to-ship engagement, and anti-aircraft defense against diving planes. The concept of a bomb that could see and think was simply outside their comprehension. The technology gap. To understand the significance of the Bat missile, one must grasp the technological chasm between American and Japanese capabilities. By 1945, Japan had entered the war with excellent torpedoes, superior night fighting techniques, and well-trained naval personnel. Their Type 93 Long Lance torpedo was arguably the world's best with greater range than any American equivalent, but while Japan refined existing technologies, America invented entirely new categories of weapons. The Bat incorporated miniaturized radar, analog computing, gyroscopic stabilization, and automated control systems, technologies Japan not only lacked, but couldn't conceptually understand. Japanese engineers who examined captured American radar equipment could identify individual components, but couldn't grasp how they worked together as integrated systems. The disparity went beyond mere technology to industrial philosophy. American production emphasized standardization and mass production. Every Bat missile used interchangeable parts manufactured to precise specifications. Japanese production remained largely artisanal with components hand-fitted by skilled workers. This difference meant America could produce complex guided weapons faster than Japan could build conventional bombs. The historical record shows the Bat missile achieved modest but meaningful success. On May 1, 1945, VPB-109 sank a second small vessel, likely a patrol boat or coastal craft, off Borneo. The squadron's war diary records this as a successful attack on enemy shipping, though the exact vessel type wasn't identified. The most significant success came on May 28, 1945, when VPB-109 attacked the Japanese escort vessel Keiboken Oni near Okinawa. The Bat missile struck the ship but didn't sink it. Oni survived with heavy damage, limping to port for repairs that would never be completed before war's end. While not a sinking, this attack on a proper warship demonstrated the weapon's potential against defended targets. On June 18, 1945, VPB-109 achieved its final confirmed kill, sinking another small patrol vessel. Additionally, the squadron destroyed at least one oil storage tank on land, proving the Bat could engage stationary targets as well as ships. These three confirmed sinkings, all relatively small vessels, might seem modest compared to the thousands of ships sunk by conventional attacks. However, they represented something far more significant, proof that warfare could be conducted by machines acting independently of human control. The other Bat-equipped squadrons, VPB-123 and VPB-124, achieved no confirmed successes. Their after-action reports described numerous problems. Radar seekers confused by land masses, humidity-damaging electronics, and difficulty distinguishing targets in congested waters. Crews often jettisoned missiles without attempting attacks rather than risk bringing armed weapons back to base. Post-war analysis by the Joint Army-Navy Assessment Committee concluded the Bat's effectiveness was mediocre at best in actual combat conditions. The weapon worked well in testing against isolated targets in open water, but struggled in the complex environment of real warfare. Radar clutter from islands, interference from weather, and the primitive nature of 1940s electronics all degraded performance. Yet even this limited success terrified Japanese naval personnel. They had no countermeasures, no understanding of what was attacking them, and no effective defense. Ships struck by Bat missiles reported being hit from nowhere by weapons that gave no warning. The psychological impact far exceeded the physical damage. The Bat missile program symbolized the fundamental difference between American and Japanese approaches to warfare. America could afford to spend millions developing a weapon that sank only 3 small vessels because the investment advanced technology that would define future conflicts. Japan, meanwhile, couldn't even conceive of such weapons, much less counter them. American production methods allowed rapid iteration and improvement. When early Bat missiles showed problems with humidity affecting electronics, engineers quickly developed better sealing methods. When radar seekers locked onto land masses instead of ships, software, though they didn't call it that, modifications improved target discrimination. Each problem identified led to rapid solutions implemented across the production line. Japanese forces, by contrast, struggled to maintain existing equipment. By 1945, fuel shortages meant ships often couldn't sail. Ammunition quality had degraded due to material shortages, and radar sets, what few existed, frequently failed due to lack of replacement parts. The technological gap wasn't just about advanced weapons, but basic industrial capacity. Behind the Bat missile's development were thousands of American scientists and engineers who approached warfare as an engineering problem to be solved. Dr. Hugh Dryden, who led the National Bureau of Standards team, viewed the project through the lens of aerodynamics and control theory rather than military strategy. His team included specialists in fields that barely existed before the war: servo mechanisms, analog computing, radar technology. On the Japanese side, naval officers trained in traditional warfare found themselves facing weapons that negated their lifetime of preparation. The emphasis on spiritual strength, warrior courage, and aggressive tactics meant nothing against weapons that kill from beyond visual range. The samurai tradition that informed Japanese military culture had no answer to American industrial warfare. The Bat missile attacks created unique psychological trauma among Japanese sailors. Death in battle they understood and accepted, but death from invisible thinking weapons struck at fundamental beliefs about warfare and honor. Survivors reported confusion, helplessness, and a sense that they faced something beyond normal combat. While the Bat missile represented automated warfare, Japan responded with the opposite extreme, the Kamikaze. Where America removed pilots from danger through technology, Japan turned pilots into human-guided missiles through ideology. This contrast illustrated perfectly the different civilizational approaches to warfare. The Kamikaze program, initiated by Vice Admiral Takejiro Onishi, explicitly aimed to counter American technological superiority through spiritual superiority. "We cannot match American science," Onishi stated, "but we have what they lack: warriors willing to die." The parallel development of these opposite approaches, mechanical precision versus human sacrifice, defined the final phase of the Pacific War. American sailors facing kamikaze attacks experienced terror similar to what Japanese sailors felt against guided weapons, death arriving too fast to counter from attackers who couldn't be deterred. But where the Bat represented the future of warfare, kamikaze attacks were the last gasp of a martial tradition being crushed by industrial modernity. The Bat missile operated within the larger context of America's systematic strangulation of Japan through technological superiority. Operation Starvation, conducted by B-29 bombers dropping magnetic and acoustic mines, had by April 1945 virtually eliminated Japanese coastal shipping. Submarine warfare had destroyed most long-range merchant vessels. The Bat missile added another layer to this comprehensive interdiction campaign. While the Bat's direct contribution, 3 small vessels sunk, was minimal, its psychological impact multiplied effectiveness across all American operations. Japanese captains became reluctant to sail even in areas where no Bat-equipped squadrons operated. The mere possibility of guided weapon attack added to the paralysis gripping Japanese maritime operations. American planners deliberately enhanced this psychological warfare. Intelligence officers ensured Japanese forces knew about the Bat missile through various channels, captured documents allowed to fall into enemy hands, radio broadcasts describing thinking bombs, and ensuring survivors witnessed attacks to spread fear through the fleet. The Bat missile represented remarkable achievement, but also revealed the limitations of 1940s technology. The analog computer that guided it consisted of vacuum tubes prone to failure, mechanical servos that required precise calibration, and radar systems easily confused by environmental factors. Success required near-perfect conditions, clear weather, isolated targets, and functioning electronics. These limitations help explain the modest combat record of approximately 100 Bat missiles fired in combat. Only a handful achieve hits. The weapon worked best against stationary or slow-moving targets in open water, away from land masses that could confuse the radar seeker. Moving targets in congested waters, near coastlines, or in poor weather often escaped attack entirely. Yet even this limited success proved the concept. Every subsequent guided missile program built on lessons learned from the Bat. Engineers identified critical technologies needing improvement: better radar discrimination, more reliable electronics, improved servo mechanisms. The Bat was less a finished weapon than a proof of concept that automated warfare was possible. The last Bat missile attack occurred on August 13, 1945, just days before Japan's surrender. VPB-109, flying from Okinawa, launched two missiles at what crews believed were Japanese vessels. Both missed their targets, a fitting end to a weapon that promised more than it delivered, but pointed toward a revolution in warfare. By war's end, approximately 420 Bat missiles had been deployed to the Pacific, with only about 100 actually fired in combat. The remainder were returned to the United States, where post-war testing continued until 1948. These tests yielded very disappointing results, leading the Navy to remove the Bat from inventory by the early 1950s. Yet the Bat's failure as a weapon system masked its success as a technological demonstrator. Every American guided missile that followed, from the Sidewinder to the Tomahawk, incorporated lessons learned from the Bat program. The engineers who worked on the Bat went on to lead development of Cold War missile systems. Dr. William Mahan, who contributed to the Bat's guidance system, later developed the Sidewinder air-to-air missile using principles proven by the Bat. Military historians debate the Bat missile's significance. Its combat record, 3 small vessels sunk, hardly seems worth the $12 million investment and massive engineering effort. Critics point out that conventional bombing achieved far greater results at lower cost. A single successful torpedo bomber mission might sink more tonnage than the entire Bat program achieved. However, this narrow view misses the Bat's true importance. It proved that guided weapons were practical, that autonomous systems could function in combat, and that future warfare would depend on sensors and computers rather than human skill. The Bat was the first step toward precision-guided munitions that would revolutionize warfare in Vietnam, the Gulf War, and beyond. The Bat also demonstrated American industrial philosophy, the willingness to invest in revolutionary technology even when immediate returns were uncertain. While Japan struggled to maintain existing capabilities, America explored entirely new categories of weapons. This approach to innovation, more than any specific weapon, determined the war's outcome. Japanese naval records from 1945 reveal confusion about what was attacking their ships. Some reports describe guided torpedoes. Others mention robot aircraft. Still others speculate about death rays. The inability to understand the threat made developing countermeasures impossible. Post-war interviews with Japanese naval officers revealed the psychological impact of facing automated weapons. They understood being outproduced, outgunned, and outnumbered, but being killed by thinking machines struck at fundamental assumptions about warfare. Several officers described feeling that they faced not just superior technology, but a different conception of what war meant. The Japanese Navy's Technical Bureau did attempt to analyze the threat, but without captured examples or understanding of the underlying technology, their efforts went nowhere. Proposals for countermeasures ranged from the practical smoke screens to confuse radar to the desperate suicide swimmers to intercept the missiles. None were implemented before war's end. The Bat missile's DNA runs through every modern precision weapon. The concept of fire and forget engagement, autonomous target selection, and standoff attack all originated with the Bat. Modern anti-ship missiles like the Harpoon and Exote are direct descendants, incorporating the same basic concept with improved technology. The ethical questions raised by the Bat about automated killing, the removal of human decision-making from lethal force, and the psychological impact of fighting invisible enemies. Precaged modern debates about drone warfare. The Bat was the first weapon to kill without human guidance after launch, crossing a threshold that military ethicists still grapple with. For the U.S. Navy, the Bat provided crucial lessons about guided weapon development, the importance of reliable electronics, effective target discrimination, and operational simplicity all emerged from the Bat's mixed combat record. These lessons informed every subsequent missile program, saving years of development time and millions of dollars. The Bat missile program statistics reveal both achievement and limitation. Total produced approximately 3,000 units deployed operationally, 420 units fired in combat, approximately 100 units. Confirmed ships sunk 3, all small vessels. Ships damaged 1. Escort vessel Ani. Program costs $12 million, $1 1945. Development time 36 months from concept to combat. These numbers show a weapon that achieved limited tactical success, but enormous strategic importance. The 3 ships sunk mattered less than the path open toward precision warfare. The Bat proved that guided weapons were possible, practical, and potentially decisive. The ASM-N-2 Bat missile stands as a watershed moment in military history, the first autonomous weapon to kill in combat without human control after launch. Its modest combat record of 3 small vessels sunk belies its enormous historical significance as the ancestor of every smart weapon that followed. For the Japanese sailors who faced it, the Bat represented incomprehensible technology that negated everything they understood about naval warfare. Death arrived from empty skies, delivered by machines that could see in darkness and think faster than humans. They were the first warriors in history to face truly automated weapons, and their confusion and terror marked humanity's entry into an age where wars would be fought as much by algorithms as by soldiers. The Bat missile didn't win the Pacific War. That victory came from overwhelming American production, superior logistics, and ultimately atomic weapons. But the Bat showed the future of warfare. Precision rather than mass, automation rather than courage, technological superiority rather than warrior spirit. Every guided missile, smart bomb, and armed drone traces its lineage to those first primitive radar-guided weapons released over the Pacific in 1945. Today, as debates rage about autonomous weapons and the ethics of automated warfare, we're still grappling with questions first raised by the Bat missile. When machines can select and engage targets without human intervention, who bears moral responsibility? How do warriors maintain meaning when technology negates human skill? What happens to warfare when killing becomes mathematical rather than personal? These questions, first posed by a 1,880 pounds glide bomb with vacuum tube guidance, remain unanswered. The Bat missile achieved little in terms of enemy ships destroyed, but it opened a door that can never be closed. The age of thinking weapons had begun, and warfare would never be the same. The Japanese sailors who died without ever seeing their attacker were the first casualties of the age of automated warfare. Their confusion and helplessness in the face of incomprehensible technology preaged every soldier since who has faced precision-guided weapons. They discovered in the most terrible way possible that the future of war would belong not to the bravest warriors, but to the smartest weapons. The Bat missile flew into history carrying more than 0 pounds of explosives. It carried the end of one age of warfare and the beginning of another, an age we're still living in, still trying to understand, still struggling to control. In that sense, the humble Bat missile with its modest combat record and magnificent implications may have been the most important weapon of World War II that almost nobody remembers.